myself Dr. P. Soumya, working as an assistant professor in the Department of Chemistry at the Institute of Aeronautical Engineering College. Today I am going to discuss about causes and effects of corrosion with dry or chemical corrosion. In this session I am going to discuss about what is corrosion, causes of corrosion, effects of corrosion, what are the types of corrosion and classification of dry corrosion, what is spilling wetwork rule. So what is the definition of corrosion? The corrosion, any process of destruction and consequent loss of solid metallic material. Consequent loss of metallic material at its surface through an unwanted chemical or electrochemical attack by its environmental is called as corrosion. Any process of destruction or consequent loss of solid metallic material at its surface through an unwanted chemical or electrochemical attack by environment, that is called as corrosion. If we take one metal, if it is placed in environment, so it will undergo some chemical or electrochemical reactions with the gases and moisture which is present in the environment. Due to this reaction, so some loss of material takes place. Loss of metal takes place. So this is called as corrosion. So the simple definition of corrosion is the process of decay of metal by environmental attack is known as corrosion. The process of decay of metal is by environmental attack is known as corrosion. So the surface of almost all metals begin to decay more or less rapidly when exposed to the atmospheric gases or other liquid mediums. So almost all the metals can undergo corrosion in presence of atmospheric gases and liquids. So examples of this corrosion is rusting of iron. So what first one is rusting of iron. So rusting of iron is the example of corrosion. So in this Fe3O4 is formed. Fe3O4 means iron oxide. So metal oxide is formed due to this corrosion. So next example is formation of green film. On the surface of copper. So this is also example of corrosion. So what are the causes of corrosion? So the metals exist in nature in the form of their minerals or ores. So we know that the metals exist in nature in the form of ores or minerals. So examples of ores, iron ore or hematite, copper ores, pyrite, bornite. So zinc ores are, these three are zinc ores. So calamite, zinc blende and sphalerite. So this is the examples of ores of different metals which are present in our nature. So these exist in nature in the form of minerals and ores in the stable combined forms of oxides, chlorides, silicates, carbonates, sulfides. So in the form of oxides, chlorides, silicates, carbonates and sulfides. So during the extraction of metals from the minerals or ores, a number of steps like concentration, roasting and smelting are involved, and finally these ores are reduced to metallic state. So here ore is converted into metal by using different steps. So hence this metal is said to be in excited state. excited state, not in the stable state. In the ore form only metal is in the stable state. So hence the isolated pure metals are regarded as excited states than their corresponding ores. So metals have a tendency to go back to their original states, original combined states. So metals have naturally tendency to go back their combined state like minerals or ores. So this is the cause of corrosion. So we are extracting the metals from ores, but the metals are said to be in an excited state. So that's why they are reacting with the environment, and again it is go back to their combined state. Go back to their combined state. So when the metal is exposed to the atmospheric gases, moisture, liquids, and the metal surface reacts and forms more thermodynamically stable compounds. So when the metal is exposed of atmospheric gases, moisture, and the metal surface reacts and forms more thermodynamically stable compounds. So this is we are telling this is as a corrosion. So here first ore is extracted and the metal is extracted from the ore during the extraction process, and this metal is not stable, so that's why it undergoing corrosion, and finally we are getting corrosion product. So this is the cause of corrosion. So metals exist in the, nature in the minerals or ore forms, but when we extracted the metals from the ores, the metals are excited state. So they are able to go back to their combined state. This is the cause of corrosion of metals. So effects of corrosion. So what are the effects of corrosion? So loss of metals. Loss of efficiency of metals or metallic materials takes place. Loss of efficiency takes place, and the valuable metallic properties. So metals have some properties. That properties conductivity, malleability, ductility, etc. are lost due to this corrosion. The valuable metallic properties are lost due to corrosion. The contamination of the product will take place if the corroded equipment is used. If we use this corroded equipment in pharma industry, the drug which is produced from the pharma industry will be contaminated. Otherwise, if we use corroded equipment in food industry, so the contamination of food takes place. So the contamination of product will also takes place if the corroded equipment is used in different industries. So also due to this corrosion, damage of metallic equipment takes place, inability to use metallic materials, and also loss of valuable materials such as blockage of pipes, mechanical damage of underground water pipes. Blockage of pipes, mechanical damage of underground water pipes takes place. So, due to this corrosion, accidents due to mechanical loss of metallic bridges, cars, aircrafts. So, in all the cases, we are using metals. So, the accidents may takes place due to mechanical loss of metallic bridges, cars, aircrafts. And also the causes pollution due to escaping products from corrosion. It is also causes pollution due to escaping products from corrosion. So the damage to hard disk and computers used to control complicated processes. So damage to hard disk and computers. In computers and hard disks also we are having some metals. So due to this corrosion, damage of hard disks and computers takes place. to control complicated process such as power plants, petrochemical facilities, pulp and paper mill industries. And also damage to commercial airplanes that could result in possible in-flight problems. This corrosion is damage to oil pipelines. Oil pipelines. These pipelines also made up of metals. So this damage to oil pipelines due to this corrosion that could cause a costly and dangerous rupture that creates significant environmental damage. That creates significant environmental damage. So this damage to bridge supports that could cause bridge failure. So in bridges, bridge supports because of the failure of bridge supports, so bridge also fails. Release of harmful pollutants from iron corrosion that contaminates the air, means air pollution is taking place. Cost of repairing and replacing household equipment, and also damage to the museum artifacts. Due to this corrosion, damage to server rooms and data centers. Server rooms and data centers also affected by the corrosion. So, classification or theories of corrosion. Based on the environment. So, based on the environment, corrosion is classified into two types. So, first one is dry or chemical corrosion. Second one is wet or electrochemical corrosion. First type is dry or chemical corrosion. Second one is wet or electrochemical corrosion based on the environment. If we take one metal, so in environment, so we are having gases, so oxygen, nitrogen, halogens, and H2S, SO2, etc. and also inorganic liquids. So based on the environment and also moisture. So based on the environment, so this corrosion is classified into two types: dry corrosion and wet corrosion. So first one is dry or chemical corrosion. This type of corrosion is due to direct chemical attack of metal surfaces by atmospheric gases such as oxygen, halogens, H2S, SO2, nitrogen, or anhydrous inorganic liquid. Anhydrous, so not hydrous. Means it is not, water is not present. So this type of corrosion takes place due to the direct chemical attack of metal surface. This metal surface, direct chemical attack of metal surface by the atmospheric gases such as oxygen, halogens, H2S, SO2, nitrogen, or anhydrous inorganic liquid, etc. Example is silver materials can undergo chemical corrosion by atmospheric H2S gas. Silver materials undergo chemical corrosion by atmospheric H2S gas. So this is example of dry corrosion. So types of dry or chemical corrosion. So this is again divided into three types. First one is corrosion by oxygen, and second one is corrosion by other gases other than oxygen, like nitrogen, H2S, SO2, and halogens, etc. The third one is liquid metal corrosion. This is due to inorganic anhydrous liquid. So 3 types of dry chemical corrosions are there. First one is corrosion due to oxygen, corrosion due to other gases, and corrosion by liquid metal, that is liquid metal corrosion. So first one is corrosion by oxygen. Corrosion by oxygen or oxidation corrosion. Corrosion by oxygen and oxidation corrosion. So alkali metals. We know that alkali metals are first group metals. So that is lithium, sodium, potassium, and alkaline earth metals that are secondary group elements. Magnesium, calcium, tin, etc. are rapidly oxidized at low temperature. At high temperature, almost all metals. At high temperature, at almost all metals except silver, iron, platinum are oxidized. At low temperatures, alkali and alkaline earth metals, are rapidly oxidized. At high temperatures, almost all metals except silver, iron, platinum oxidized. They can be oxidized at high temperatures. So this is the corrosion by oxygen. Here, mechanism of corrosion by oxygen. In this, oxidation takes place at the surface of the metal, forming metal ions. Oxidation, corrosion by oxygen means metal reacts with oxygen and forms metal oxides. Oxidation takes place at the surface of the metal, forming metal ions. So metal can undergo oxidation and forms metal ion and electrons. Metal and electrons. Here they have taken metal. It is converted into metal ion and two electrons. This metal ion reacts with oxygen. Before that, these electrons taken by the oxygen which is present in the atmosphere and forms oxide ion. This oxide ion reacts with metal and forms metal oxide. This metal reacts with oxygen and forms metal oxide. So metal oxide. So this is the mechanism of corrosion by oxygen. Here this is the metal, and in this inward diffusion of oxide ion is taking place. So due to this in diffusion, the metal ions are releasing the electrons and forming metal ion. And these electrons accepted by the oxygen which is present in this atmosphere and forms oxide ions, and these oxide ions and metal ions combine together and forms metal oxide. So this is the mechanism of corrosion by oxygen. So in this, metal and oxygen reacts with each other and forms metal oxide, that is corrosion product. So this is corrosion due to oxygen. Here corrosion product is metal oxide. So example of this is oxidation of brass. So initially here what is happening, metal is reacting with oxygen and forms metal oxide. So total surface which is exposed to the environment, it can undergo oxidation and forms metal oxide. This is metal. So initially the surface of the metal undergoes oxidation, resulting metal oxide scale forms barrier which restricts the further oxidation. So the extent of corrosion depends upon the nature of metal oxide. Due to the oxidation of this metal oxide is formed. The extent of corrosion depends on the nature of metal oxide. If the metal oxide layer is stable oxide layer, the formed oxide layer is stable oxide layer, a stable natured corrosion product do not possess any cracks or pores. Hence, it stops the axis of oxygen on underlying metal. If the oxide layer is stable, and it do not have any cracks or pores, any pinholes. So that stops the axis of oxygen. So that axis of oxygen underlying the metal. So this layer stops the oxygen which is to the underlying metal. So due to this corrosion, the further corrosion is not takes place. Further corrosion of metal does not takes place because a stable oxide layer is formed. Example of stable oxide layer is the oxide films on the aluminium, tin, lead, copper. Aluminium, tin, lead, copper. And these are tightly adhering and impervious in nature. The metals, the aluminium, tin, lead, copper, they forms stable oxide layers. So this does not undergo any corrosion after forming this stable oxide layer. If that layer is unstable, if that oxide layer is unstable, this is formed on the surface of noble metals. This formed on the surface of noble metals, silver, aurum, platinum. So noble metals are silver, aurum, platinum. Here oxidation is taking place, but that layer is not stable. So that's why it decomposes back into the metal. And oxygen. Hence, the oxidation corrosion is not possible with metals. Here, metal is undergoing forming metal oxide. But the metal oxide layer is not stable. So, that's why it is decomposes back. Here, metal and oxygen forms metal oxide. So, it is decomposes back. So, metal oxide again converted into metal and oxygen. So, here corrosion is now takes place for the noble metals such as silver, aurum, platinum. If the oxide layer is volatile, means it will easily evaporate. It will easily evaporate. If it is volatile, so what will happen after some time? So like this, we will get fresh metal. Fresh metal is again available for the further attack. So this layer is volatile, means it will evaporate after forming metal oxide, and it is giving fresh surface to the environment, and again corrosion takes place. So the oxide layer film volatilizes as soon as it is formed. Hence, always a fresh metal surface is available for further attack. This causes continuous corrosion. So, example of this is molybdenum. Corrosion or oxidation of molybdenum. So, it will form molybdenum oxide. So, MoO3. Molybdenum oxide. This molybdenum oxide is volatile in nature. So that's why the continuous corrosion takes place for molybdenum metal. Here, metal is reacting with oxygen and forming metal oxide layer, and it evaporated. So that's why fresh surface is available for corrosion environment. So again, corrosion takes place. If the formed oxide layer is porous, means it is having some pores. It is having some pores. Means some area of metal is exposed to the environment. Exposed to the environment. So through this pores and cracks, the oxygen will go into the metal and undergo severe corrosion. Undergo severe corrosion. So if the oxygen is a porous layer, the layer having pores or cracks, in such case, the atmospheric oxygen have access to underlying surface of metal through the pores and cracks of the layer, thereby corrosion continues till the entire metal is completely converted into oxide. Till the entire metal is converted to completely converted into metal oxide. So examples of this type of oxide layers are alkali and alkaline earth metals. So alkali and alkaline earth metals, sodium, potassium, lithium and magnesium, calcium, like that. So these forms porous layered oxide layers. So due to this, continuous corrosion takes place up to total metal consumed. So next one is corrosion. Second one is corrosion by other gases. First one is corrosion by oxygen. Second one is corrosion by other gases. Corrosion by other gases like sulfur dioxide, H2S, CO2, nitrogen, etc. Other than oxygen, the corrosion by other gases other than oxygen, the like SO2, CO2, H2S, etc. The degree of attack depends on the formation of protecting or non-protective films on the metal surface. Here, this is also forming some film, means some corrosion product is here. So, this extent of corrosion depends upon the layer which is formed due to the corrosion. So, example is if the film formation is protective or non-porous. Protective or non-porous means that is stable layer. Protective, stable layer is forming. So this is acting as a protective layer, and due to this, further corrosion is not takes place. So AgCl example of this type of corrosion is AgCl film resulting from the attack of Cl2 on Ag. Means Ag reacts with the Cl2 and forms AgCl. So this silver chloride on the silver chloride layer is formed. This is acts as protective layer. This is acts as protective layer to the silver metal. So that's why the further corrosion is not takes place. Further corrosion not takes place. So the intensity of corrosion decreases because the film formed will protect the metal from the further corrosion. So if the film formation is non-protective, if it is protective, it can act as a protective layer and there is no further corrosion. If it is not protective or porous, the surface of the whole is gradually destroyed. Surface of the whole metal is gradually destroyed because that is non-protective and porous layer. So example of this type of corrosion is dry Cl2 gas attacks on the tin. Here tin is undergoing corrosion in presence of chlorine gas and forms tin chloride. So this layer is acts as non-protective or porous layer. So due to this, corrosion takes place. Continuous corrosion takes place. So this is about corrosion by other gases. So next corrosion is liquid metal corrosion. So next corrosion is liquid metal corrosion. This is due to chemical action of flowing liquid. Chemical action of flowing liquid metal at high temperatures. At high temperatures on solid metal or alloy. If we take an alloy, flowing of liquid liquid metal, that is also metal. Flowing of liquid metal at high temperatures. At high temperatures. So this type of corrosion takes place due to chemical action of flowing liquid metal at high temperatures on solid metal or alloy. So this type of corrosion is called as liquid metal corrosion. Means corrosion takes place due to flowing liquid metal. So this is called as liquid metal corrosion. So such corrosion occurs in the devices used in nuclear power. So here the corrosion reaction involves either dissolution of solid metal by liquid metal or internal penetration of liquid metal into solid metal. Here corrosion takes place in two ways. Dissolution of solid metal. If we flow the liquid metal on the solid metal, if the dissolution of solid metal is in liquid metal takes place, then the loss of solid metal takes place. That's why due to dissolution of solid metal, the corrosion is taking place. First one is due to dissolution of solid metal in liquid metal, the corrosion takes place. Second one is internal penetration of liquid metal. Internal penetration. If liquid metal is internally penetrated into the solid metal. Here also some loss of solid metal takes place. Loss of solid metal takes place. So in two ways the liquid metal corrosion takes place, by the dissolution of solid metal by liquid metal or the internal penetration of liquid metal into the solid metal. So example of this is coolant leads to the corrosion of cadmium in nuclear reactors. In nuclear reactors, sodium metal acts as used as a coolant, and cadmium rods are used as a cadmium rods also used in this used in the nuclear reactor. So when this sodium metal is flowed in this cadmium rods, the cadmium rods undergo corrosion. So example, coolant leads to corrosion of cadmium rods in nuclear reactors. So example of liquid metal corrosion is coolant, which is leads to corrosion of cadmium in nuclear reactors. This is about liquid metal corrosion. So, pilling bedworth rule. So what is the pilling bedworth rule or PB ratio? So it is the here metal is undergoing corrosion and forms metal oxide layer or any other layer. If we take oxygen, so it is forming metal oxide layer. So the pilling bedworth rule is the ratio of volume of metal oxide formed and to the volume of metal consumed. Volume of metal oxide formed by volume of metal consumed. So this is the ratio of pilling bedworth. So it is also called as PB ratio. So pilling bedworth ratio is volume of metal oxide formed by volume of metal consumed. If PBR is less than 1, the PBR ratio is less than 1, metal oxide is porous. The formed metal oxide layer is porous. If PBR is, the pilling bedworth ratio is greater than 1 but less than 2. It should be greater than 1 or should be less than 1. Less than 2. So in that case, metal oxide which is formed is non-porous and protective layer. It should act as protective layer and it is non-porous. If PBR ratio is greater than 2, embow, the metal oxide film cracks and do not protect. If PBR ratio is greater than 2, it should have cracks and it should act as a non-protective layer. It acts as a non-protecting layer. If PBR ratio is less than 1, metal oxide is porous. If PBR ratio is greater than 1 but less than 2, so that metal oxide is acts as a protective and non-porous. If PBR ratio is greater than 2, that metal oxide layer is contains cracks and it is acts as a non-protecting layer. Using this Billing-Wedgworth rule, so we can tell which is the nature of metal oxide layer. Nature of metal oxide layer. So this is about Billing-Wedgworth rule, and thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.